Hey guys, welcome to Road to Artificial General Intelligence. My name is Amritansh and I'm an AI researcher. And with me, I have Tamal Acharya, another AI researcher and AI professional. Hey Tamal, how are you? And would you like to introduce yourself?
Hey, Amritansh, yeah, I'm doing good. Hi everyone. I am Tamal. I am in this domain of AI and ML for the past 8+ years, and I'm a part-time researcher in the domain of AI and ML and also quantum computing. And yeah, so I always have this fascination with artificial general intelligence. So I met
Mhm.
Amritansh a while back. I've got a few years back, and we stuck. We had common interest in this AGI field. So yeah, we stuck, and here we are doing some podcast.
Thank you, Tamal. Thank you so much. So primarily, I would like to let everyone know that this would be kind of a series of videos, and we might even do some live podcasts at some point. But right now, we are gonna start with these video series, and this particular video is gonna be kind of like a follow-up to my previous video, which I recorded and we put up on YouTube, as a matter of fact, into November. I think it was November 2017, and you can find that video, and we'll be putting all the links in the description as well. So the video is called The Dream of Artificial General Intelligence. And over a period of time in 2018 and 2019, we were also able to work with few other researchers and we were able to publish few Medium blogs. And these again are very AI centric and mostly pertaining to the history of AI. So I would really recommend you guys to look into Story of AI and the Dartmouth AI conference. Both can be found on Medium. So make sure you go through it. But we are not gonna look into history much this time. This time we are looking into kind of how we are going to reach to this idea of AGI. And for the purposes, we are trying to avoid the discussions in too many directions of AGI because, again, the fundamental of AI or automated intelligence has been around quite some time. Even Aristotle in his philosophy has mentioned about some ideas where we want to automate our processes and work. But let's see what we can really do now. And with all the modern AI advancements, what is possible, what is not possible, and where should we go beyond this point of time in life. So it's an exciting journey. I have been into the field of AI for more than 5 years now. So I would really like to see some serious discussions in AGI, and I would like to kind of take active part in this discussion. But before we go to AGI, let's define intelligence. Okay, and this is a big problem because defining intelligence is really hard. And like any serious researcher will tell you in this field that we don't have a solid definition of intelligence. And I do not think that even I know a solid, as a very foolproof definition of intelligence itself. But even if we do not know a foolproof way or like full kind of a very solid way of understanding intelligence, we can have some definition. And even without having a very fixed definition or 100% right definition, we will move forward in search of AGI. I particularly like what McCarthy said. Okay, intelligence is basically the computational part of our mental ability to basically achieve goals in the world. Varying kinds of intelligence and degrees of intelligence occur in different humans, animals, and even some machines, maybe. Okay. Although Dr. Pei Wong has put a constraint, then when we start saying this ability, okay, mental ability, we need to be very clear that we are dealing in insufficient knowledge and resources, and it also means any intelligence system that we build or whenever we are measuring or kind of benchmarking something, we should always remember we have finite processing capacity. It should kind of work in real time and it should be open to work in unexpected scenarios, tasks, and it should be able to learn from experience. So we are not looking into physics definition like where we build a massive quantum computer which can estimate every position or like position and the like a position velocity of every particle or quantum particle, and thus we know everything, and then thus we can predict everything. That is not what we are looking in intelligence. We are inherently making this assumption that the environment is never gonna be like we will have uncertainty, we will have variations. Okay, and thus we will have to define intelligence and we will have to work with these constraints all the time. And again, I think team Marcus Sutter and his team did like amazingly well, good job, I think, in their 2006 paper, and where they have kind of discussed various definitions of intelligence, and then they have also kind of put up their own definitions as well, like idea of universal intelligence of agent pi. And basically, they also have like talked about this mental capability, and where they are talking about ability to reason, plan and solve problems, think abstractly and comprehend different ideas, right? And when we think about human intelligence itself, so rather than directly going for machines, if we just were to think about human intelligence, kids at from a very early age are able to show some signs of intelligence, which can be very unsupervised or self-supervised. So I have a niece, and when she was barely 2 years old, she kind of figured out that if you press the thumb of a person, the phone unlocks. Okay, of course, she didn't understand the mechanics of it, how it happens, but she was able to see that pattern. That's how the adult will unlock their phone, and maybe I just need to replicate that behavior. So in that fashion, I would like to ask Tamal. Hey Tamal, so do you think humans being human are basically intelligent?
Yes, I do like to think we are an intelligent species. We started by building stone tools, caves, living in caves, and we have come all this way to now we are in a position where we are thinking of building a system which will replicate us. So yes, we have
Sure.
come a long way, and I think we are intelligent beings. Yes.
Wonderful, wonderful. Although this is like something that you want to discuss, so I will let you take lead here, and let's discuss the type of intelligence, because I do not always want to say intelligence in terms of mathematics and logical processing that we all know, and we kind of always have focused on IQ, but we do understand that there could be different sensibilities or different dimensions to intelligence. So Tamal, why don't we discuss this?
Yes, that's right. Yeah, thank you. So intelligence is a very fascinating thing. Now, Howard Gardner, in his theory of intelligence, he put forward the 9 types of intelligence. Now, you can go through the details in his paper, but I'll
Right.
give a quick overview of what the 9 types of intelligence are. Now, I'll go clockwise. The first one is spatial. Spatial intelligence is the one as you are seeing the world in 3D. It is as you're seeing with your own eyes, trying to understand the world around you. So that's
Hmm.
spatial intelligence. The naturalist intelligence, you're trying to figure out the nature around you. So trees, birds, animals, flora, fauna. So all these things. So these are naturalist intelligence. Next is musical. Now we do sing songs, we hear music, we dance, we do everything with music. So that's musical intelligence. Logical and mathematical is when we do some tasks. Say, for example, we are giving some exams, some solving some complex problem, doing research, where you use your logical and mathematical thinking to do those, to solve the problems. So the next is existential. Now, existential is more like a philosophical point of view, like where do we come from, where are we going, why are we here, are we alone in the universe? So these kind of questions, which actually deals with existence. So that's existential intelligence. Next is interpersonal intelligence. We do, I mean, every day in the workplace or anywhere, if you meet a friend after a long time, you very often come across these questions like, are you feeling okay? You are not looking good. Your body language. So we try to understand the body language of the other person and trying to figure out what's going on in his or her life. So that's interpersonal intelligence. Next is bodily kinesthetic. So this is more like aligning your body and mind. So martial arts, yoga, meditation. So all these things comes under this bodily kinesthetic, where you are aligning your body. So next is linguistics. So very often we see that as we are giving a presentation and if you give a public speech, we try to practice as well in advance. For example,
Yeah.
month before we form the words and we form everything. So that linguistic, we form trying to form the words that will be delivered. The last one is the intrapersonal intelligence. So this is like understanding your own self. So that is why, how am I feeling today? Why am I sad? So these kind of questions, why you are dealing with yourself. So that's intrapersonal intelligence. Now, human beings show all the 9 kinds of intelligence. You use them every day. Now, to
Sure.
build a system that will replicate a human being, I believe and I think we should be able to replicate ideally all, but if not all, at least some of them.
Okay.
What do you think?
Yeah, definitely. And I would like to actually extend this point, and I would like to think that yes, these are kind of different dimensions that you have put. But I always like to think, and in various neuroscience research, we have seen that actually that even the information like you can provide visual information, let's say through you via your tongue, and the brain will initially see it as noise, and after a while it will start to make sense of it. So I would like to think maybe there is some connectivity. Yes, these do look very different to us, but what if there are some commonalities? And this is where the discussions about AGI will start. that yes, fine, you have described different dimensions, but what if brain fundamentally does something, let's call it some kind of a master algorithm, okay, that it puts some master algorithm at the end of the day, although we do not know, it's a theoretical concept. So let's discuss that rather than always thinking in different dimensions of intelligence, what if there is a common link or kind of a common thought or common process that brain follows? Now, these can be still a set of processes. I'm not saying these are like a unified process. Okay. So AGI, or artificial general intelligence, refers to an idea where a machine shows multidimensional or polymath level of intelligence or synthetic intelligence, which is similar to what human intelligence is. And the idea would be like it would be able to solve variety of problems, and it would be able to use transfer learning successfully. So what we mean here is, and I want to be exceptionally clear here, okay. And because Jan LeCun has kind of reignited this debate I think last month itself in February, and basically he said this same thing that humans are not general intelligent anyways. Now, I would like to say, of course, because we are inherently limited by our biological limitation that we have, okay. And I would like to say, or I would like to understand that how humans learn, or what humans, the processes that human brain basically implements. What if we were able to emulate them on machine? And then machines, on being virtuous that they do not really get tired up, or they do not really get bored, and they can just keep doing things. And because everything is working on levels of copper or optical fibers, which is almost the speed of light, it is much faster. It doesn't really has the backlogs of the human brain, which is biological and given slow, right? By that definition, it is slow. Okay. So our idea would be to figure out these processes or set of processes, okay, and build a system which could be something like Ex Machina, if you have seen that movie, and kind of think about this AGI in terms of like how we can emulate human intelligence, because that is the benchmark. Someone can say, why only human intelligence? Because so far we have not met an entity, or like we have not envisioned an entity which is gonna be much intelligent than human beings. Every measurement is based on human, because we are biased in that direction. We do like to think we are the most intelligent beings around. So it has become a benchmark over there, and the first task would be to bring the artificial general intelligence around this human intelligence idea. So Tamal, what do you think about AGI? I understand it's a philosophical or a theoretical concept, but what are your thoughts?
Yeah, what I've seen in the movies, TV series, it has been there for quite some time. The idea is floating
Yeah.
around super intelligent system which will at least take some of the task and do everything. So what I believe is that AGI still now, even though it's a theoretical concept, but we are slowly and steadily going there. Like there are systems which like DOTA and others. So though, although they are not at that level, what we are thinking, but yes, they are there. We are just taking the first steps. But I think we're still a long way to achieve
Yeah.
the kind of intelligence that are being shown in the movies and in the TV series. But yes, I would like to be, I mean, we are in a much more fascinating period in our time. Like, I would like to think that in few hundred years, I think we'll be there. We'll achieve a system that
Yeah, a lot of
will
people
be
are much
intelligent.
optimistic.
And
100 years, yeah. You will be called the pessimist in this group. But yeah, definitely. Even I would like to say that, oh God, let me see this. It looks like Tamal has dropped off. Hey, Tamal, are you there? I think I lost your video. Yeah. Okay, anyways, I think we can continue. Hello.
hello.
Hey,
Very
Tamal, can you hear
sorry.
me?
I don't know what happened.
Something happened.
Tell me.
Okay. Let's wait for AGI to explain this. But with our human intelligence, we would like to think that there are like a lot of these narrow AI systems, and there have been tries. It's not that we are the people who are really looking into it. There have been some serious tries. And if you remember the earlier pioneers of AI, like Turing, McCarthy, Minsky, Solomonov, and sorry, this is reference to Dartmouth conference itself. We have not realized most of the dreams that were set. Maybe they were too ambitious. They did not realize at that point that they were too ambitious, and it was really hard to replicate even artificial narrow intelligence in a lot of sense. Okay, there have been scenarios. I think Deep Blue Chess, IBM Watson's Jeopardy win, and OpenAI systems for Dota, AlphaGo, AlphaZero, and recently Facebook came with Data to Vic. Okay, and there has been a model by Sony, which is Gran Turismo Sophie, which is really good actually. When I've seen the YouTube videos, it looks really good. But still, I would say that we are not even close to it. And Jan LeCun himself said, no system would even rival like the intelligence of a house cat. And I will say no system might even kind of compete even with the mice that is found in our home, because there is no generalization over there. And a lot of researchers have pointed this out. There have been ideas about world models, and we will talk about world models a little bit later as well. And there, anything that we have developed, according to me, is artificial narrow intelligence. And we would like to kind of build it like, and we want to be very sure when we say these things that it is doesn't mean we are discarding any work that has happened. I think these all are very good stepping stones on which we are going to build actual AGI. But let me be very clear that I don't think so any true AI or AGI system has been yet realized till this point, as a matter of fact, in history. But anyways, let's see like what else we want to learn about here. And I want to compare. I want to have a comparison, fair comparison with the existing state of the art. So according to you, what is the existing state of the art?
For me, the existing state of the arts are the systems, Dota, StarCraft by DeepMind, AlphaGo, which they beat the world champion Go player. These are the existing state of the art that are existing right now. But as you correctly pointed out, and I agree also, that these systems are nowhere near to the system of what we are thinking of building, like a human intelligence level system. They are actually designed to do specific tasks, and that's what. So take that algorithm of Go, and if you try to tell him to do something else, it will fail because it hasn't seen
there
that.
is there is other critique that okay, Go and chess, I know these are complex. Go is much more complex than chess itself, but the bigger problem that we run into, I think, is they're still very deterministic in the way they are played. Okay, there are very set rules, and even the critique was if the rules of chess are changed, then again Go would have like the same system would have a lot of problem, but a human will require a very less amount of retraining. So let's say you figure out the like how do I say, like different pieces, like horse moves, rather than moving 2.5, it starts moving 4.5. Humans will adjust much faster, but because you are inherently using reinforcement learning, it will take much, almost like it will take massive amount of training. Again, a lot of hit and trials for the same system which has learned so very well to play that same chess game. And you are like, okay, change just 1 or 2 games and then see the bishop moves rather than bishop moving like at a certain like a diagonal. Like if I remember correctly, if that starts to move straight, then what happens? So there have been these issues like, okay, these are very hard set and deterministic rules. But anyways, coming to that exact same point, and I think we have some ideas about what should be the requirements, like what you would actually want to see over there. And there have been like theoretical replication idea has been like suggested by Church during thesis itself, that given infinite time and memory, it is possible. But that is the biggest problem. Like we don't really have infinite time and memory. So in limited time, what we can do, that is the point. And we would like to point that, okay, first thing is common sense. Now, common sense, easier said than done. It's really hard to define even. And it's common sense itself is not that common, okay? And a lot of researchers basically point out that common sense is like building a world map or like some kind of a world model. Like, again, I am kind of referring to Jan LeCun a lot, but his a lot of conversations have been very relevant to our research as well. And recently, when kind of pointing to world models, again, he said the same thing, that common sense is nothing that you understand your world fundamentally, like you understand how your world works. And based on that, you can figure out some maybe shortcuts or like you can say some extreme optimization, which would appear to a person like, oh my goodness, like this is so simple. But unless you don't have a deep understanding of the system, developing a common sense solution is incredibly hard. And similarly, and this refers to the exact second point that we have referred, background knowledge. Like unless you don't have background knowledge of the system, you can call them inductive biases, okay? Again, some kind of a world model, how the world is working. And again, you will require some knowledge base because our knowledge is currently expanding, I think, exponentially every day. So unless we do not build this massive knowledge base and we do not provide inductive biases, I don't think so we will be able to implement common sense or any of such ideas. And then the third thing is also highly connected. Unless that doesn't happen, you just cannot have transfer learning. Maybe you can think like, okay, I have some transfer learning at image level and even with transformers at NLP level. But if you keep changing the domain, it doesn't really work very well. Like you cannot take the same transformer that you just trained for your NLP data and just say, okay, let's let it work for images. No, you will require a brand new retraining for this. Otherwise, it doesn't work. That's not the real case with human brains. Like I know, like even I have tried to learn some foreign languages and it has been tough for me, but I was able to pick up some basics. It was not completely missing on me. Okay. So, and the same brain is also doing the visual processing, sound processing. It also understands taste, and it is also thinking abstractly about a lot of ideas, right? And then abstraction, as I just mentioned, like abstraction, as we study, as we kind of develop our own knowledge, we start to build abstractions one after another. So when I say 2 to the power 4, or maybe your brain will say 16, right? Immediately, right? You, very few people these days, once you are very well versed in mathematics, you will very rarely will be doing like 2 into 2 into 2 into 2, right? People don't do that. They kind of almost know that what is that power operation. But maybe I can also say the way computers will do, they will actually start adding 2 that many times. So that is a weird thing. Like we don't want to like don't want to like start from first principles every time, or like want to do every calculation from scratch. A lot of these abstractions, any mathematical formula, I can simply say it is going to be an abstraction to existing knowledge. And the ultimate point, when once I have put the idea of formula or equation, but then comes the problem of causality. You can always figure out correlations. Okay, given 2 numerical columns, I can figure out correlation, however weak it might be. That's not the concerning. But when the concern becomes, when we have strong correlation, does it also means A is causing B? Like, so in equation and mathematical equation, things go both ways, right? So you can imagine y is equal to x plus 5, right? But you can also say x is equal to y minus 5. Both are same things. Both are exactly the same things for us. Mathematically, that's not how things, or sorry, in real world, that's not how things are supposed to work. Maybe you can do A to B, but you cannot go B to A. But who will explain that? Who will explain this to machine at the end of the day? So unless we do not, and Judea Pearl, one of the leading researchers in this field, has kind of mentioned like we have not gotten the right tools to so far deal with causality, how to express causality to machines. And without that, it's going to be incredibly hard, especially the discussions around system 1 and system 2. Like the system 1 is the quick thinker and system 2 is the one which will really analyze everything. And causality has to be described very well. Maybe system 1 can make small mistakes. It can just jump on correlations. But system 2 has to really think or like kind of process the idea of causality that, okay, fine, A to B can happen, B to A can't happen. But how do I explain that? And that is still a problem. And comparing it with, but before I go with the deep learning comparison, I would like to ask, like, so we have been listening to Dr. Ben Gorgel. So what do you think about his core AGI hypothesis itself?
Yes. So core AGI hypothesis is one of the important hypotheses which he has formulated, and we would and we should be adhered to this hypothesis. He says that basically the research and the effort that we put in researching a system that is meant for a generalization or the general level intelligence is much more different than researching and putting effort to devise a system that is meant to do specific tasks. Now he says narrow AI. So in simple words, what he says is that researching for artificial general intelligence is much more different than researching for artificial narrow intelligence. Narrow intelligence is the systems that we saw earlier, like a DOTA, Sony's system, the Sophie. So these are artificial narrow intelligence. So they are meant for specific tasks. Now, Dr. Bengal clearly pointed it out that these two are completely different. Now, we should be careful when we are trying to research or put effort in devising some system. We should not be making a system that is narrow, but we should be at least thinking of a system that is more general in a way that it is supposed to do things.
True.
Now, yeah, yes. And now the next slide, he kind of lays down the 10 pointers, like what the system should be able to do. Now, first one is it should realize some symbol system. Now, we humans are very good at that. We have been dealing with symbols since our birth. I mean, whenever we see some symbols, we try to associate some meaning to it. We know what that means. So we identify symbol system. Now the AGI system should be able to do that. Next one is have a fixed structure to the task. Now, this is for us humans, this is very, very common. So, for example, when you're trying to solve some task, suppose I'm given a problem. Now I'll think of some of the steps I should take to solve that task. Now I have a fixed structure in my mind. Now that steps might change after discussing with people, or I might think that these steps might not work, but at least I have some steps. So the system should be able to do that as well. It should have some fixed structure to a task.
Yeah.
Now 3 to 8, what he says various kind of knowledge levels that the system should have. Now we human are good at that. Every day we try to learn new things, even from cross domain. We try to learn something. If you are in, say, for example, a physics student, it should not stop you from learning philosophy. It should not stop you from learning literature. So we expose ourselves to various domains all the time to gather information, try to make sense of the things around, because we live in a world where if we don't know many of the things, we might not be able to grow, we might not be able to cope with the pace with which we are developing. So the various kind of knowledge, what he said, like from point number 3 to 8, like we should be able to, the system should be able to show those level of knowledge as well. It should be able to explore the world on its own. It should be able to gather knowledge from various domains, be it his own domain or some other domain. It should be able to do that.
Yeah,
now,
I agree.
It should also support incremental or online learning. Now we human are very good at that. Now we have this 1% rule, like we should be able to develop ourselves or grow ourselves 1% every day. What we are today should be different from what we are tomorrow. So there should be an incremental growth of our in terms of knowledge or anything. So that's how we grow, that's how we so there are various books published to it, like the Atomic Habits. So this one, so the system should be able to show that as well. So this is what Dr. Ben Gorgel has pointed out correctly. All these 10 points they should be able to do. Like we human are very good at all those 10 points.
Yeah, I agree. Even I have been reading Atomic Habits. It's a good book. Yeah, definitely. And again, coming back to this idea of deep learning, because even in all frankness, like within our company, we have used deep learning for past 3 years while developing our product and working with so many clients. But we have faced a lot of issues, and kind of these pointers are like something very well known to most people. But again, I would like to kind of point here that the generalization capability is very big, big concern. Okay, first of all, of course, neural networks have a tendency of overfitting. Although, okay, we can reduce that. Okay, we can have a variety of data, or like very randomized data, and it should have variations and everything. And we can have regression, kind of batch normalization and dropouts, and we can do a lot of things to cut down on the overfitting. But the problem is generalization, the core essence of generalization, and I think it is very true for any machine learning algorithm, as a matter of fact. Transfer learning is again like in same domain. Maybe you can do that. Maybe if you teach about various other animals, teaching about a new animal or image of a new animal is not a big deal. We can definitely do a retraining. And I remember, like, I give this problem to some people and I simply tell them, okay, you have this ImageNet data set, and maybe now you can take a Stanford dog classification, dog breed classification, and you can use transfer learning. So you can take some state-of-the-art ResNet model and you can retrain on very less amount of data. So per dog breed, maybe you will not even have 50 images, but because it's already a very pre-trained model, it doesn't take that much data anyways. But the problem is that model doesn't translate very well into, let's say, if I were to just write poetry from that, right? The third one is the biggest, I think, the culprit here right now with the climate change that's happening all across us. And still, even in India, I don't think so. Most of our energy grids are truly green. We are kind of burning coal at the end of the day. For most of our grids are still very thermal at the end of the day. And so as more graphics card you have and a single GPU, I think even if you have here, or maybe it is on some kind of a cloud server, it would be one single graphics card will be like 250 watts. Plus there is a lot of hardware which is supporting motherboard, your CPU and everything, right? So if you have 4 graphics card, like 1000 watts are consumed within 1 hour, and that is just the graphics card. Of course, we are not even factoring the CPU and hard disk and the processor, cooling equipments and everything that you will require, because 4 graphics are, you have to cool it, otherwise it is just gonna go bonkers. Strategy and planning is one of my biggest complaints as well. I do not see any serious, like, how do I say? I have not seen any particular model. I have kind of dabbled a little bit into RL and have seen these outcomes of Dota and StarCraft, I think, recently. And I'm not convinced about long-term planning. Short-term, yeah, they are able to do really well. But long-term planning is something that I think it still escapes the realms of deep learning. Maybe we need to put some inductive biases over there, or maybe without world models, I do not see it happening. Search space optimization, although you can say with transfer learning, you don't have to really do that much, but still it will be a massive search when Like once you are dealing in billions or trillions of parameters these days, finding the right search, like your parameters will take a long time. And that optimization is still very missing from deep learning. And of course, we don't have inductive biases. Okay, so I want to say in absolute sense, we do not have inductive bias, but that would not really be true. Any kind of particular model that you design is having inductive bias. So you know, like for images, CNNs are doing better. It doesn't like it didn't happen magically that all the artificial neurons arrange themselves in a convolutional layer. No, we literally put a convolution layer. Some people I remember recently put a Fourier transform. So they put Fourier function on a neural network layer. That is inductive bias. You understand why it works so very well on images. Machine did not figure out the Fourier was the right function over there. I think I have talked about causality, so I'm not going to go there, but the same problem, it doesn't understand. At the end of the day, maybe there is a high correlation. That is why you are getting some good result, but it doesn't tell us anything about causality. And because of these problems, like there's no inductive bias, there's no causal relationship, this gives a black box nature to the overall idea. And a lot of good research is happening, I think, in interpretability and explainable AI, but deep learning does really seriously requires this. Otherwise, in a lot of domains like healthcare, I think in law as well as in I think finance or banking, it would be incredibly hard to really make these state-of-the-art models work over there. Even if they're good, I'm not denying their efficiency in the narrow task, but they really cannot be used. They can be really troublesome if they start to get something wrong. And it is hard to explain. And that is the biggest thing. And I remember this point that in USA, I think some companies sold this computer vision models and they were mostly trained on Caucasian white males and females. Okay, so they had like massive, they were giving like, how do I say, massive false positives on like people of color at the end of the day in USA. A lot of people were getting misclassified. So it can be a disaster to those communities at the end of the day, because let's say you did not factor that in and you cannot even explain how did your model learn really. Maybe you had some less images, but then what really happened, where we need to tinker, what we need to fix, apart from data only. If we are trying to control the epistemic error of the deep learning, where do we really start? I think the explainability and interpretability of deep learning models would be really handy, but so far still I think it is lacking. So this is the slide we added for like people who keep like asking us like what really, if you want to get into AGI, what do you need to do? I always say like I do not know the fixed answer because no one has seen AGI. So it's like, how do I tell you what it is, right? But I think few topics are always going to be important. Logic, of course, mathematical logic you have to develop. Okay, without that, I don't think so you're going to go forward. The second thing, if you're dealing with stochastic random world without probability theory, how are you going to ever explain it? And once you start working in discrete systems, any computer system which is discrete, you have to have graph theory, any kind of knowledge base that you might have to build. I'm not sure how to build a knowledge base. We will have some discussions on knowledge base, but so far I'm not 100% knowledgeable in this field itself. The fifth one is which everyone is behind, right? What set of learning algorithm? What do we do? Do we customize the existing neural networks, or do we do something else, or we mix multiple ideas like RL plus DL plus online learning and whatnot? Okay, people keep pushing these ideas. So on the sixth one, evolutionary computation, I'm not 100% sure like this is gonna go, but again, a lot of people have kind of their like valid ideas that evolutionary computation might be able to help us because that's how human intelligence has developed. So maybe we should look into that. Robotics is definitely important for any physical manifestation of whatever we are trying to do, because otherwise we are doing everything at a software level. So at some point, advances in robotics would be important, although that is where the trouble might actually start. Okay, because that is the, I think, the storyline of the Terminator at the end of the day, right? If it was just a software, it might have been like close to a Matrix scenario, but once it becomes like the hardware thing, then it can become a Terminator scenario real fast. But again, those fears are I think, much blown out of proportion, as in age of, let's say we are in 2022. I think that those are blown out of proportion. I'm not saying they're wrong. There are valid concerns, but like we are not very close to what AGI should be, okay? And of course, the ultimate thing I always like to tell people is our human intelligence became so powerful because we've learned to cooperate at the end of the day. So multiple intelligent agents came together and build this society, build languages, and build our overall economies and whatnot. So one of the impacts we are just literally seeing in Russia war, like everyone is putting like sanctions on Russia, and maybe, I do not know the outcome of the war. Let me be very, very clear. But you can see the impact, like how, because multiple countries and multiple nations work together to make this world possible. Once you start cutting it off, and then you start to see the problem that even a single country or a single entity might face after that. So without multi-agent, I do not see that how would we ever be able to kind of achieve AGI. So this is something that I would really like or ask people to consider. So these 8 points, ideally, you should definitely look into it. Of course, there is neuroscience, there is different fields of mathematics, even physics you can look into, but I think these are important. So, Tamal, basically the idea is when we talk about what is missing, according to you, now, of course, I have mentioned a few things. What do you see, like what we could do here? I want to ask you now.
Yes, it's a very good question. I mean, I see a big gap between what we are doing currently
Hmm.
and what we are supposed to do. I mean, supposed to go like the field of AI started in the Dartmouth company dreaming. Those people dreamt of a system that is capable of mimicking a human being. Now, over the past decade or past 50, 60 years, nothing
Right.
has happened. I mean, although we have seen various state-of-the-art systems and all, but they are nowhere near to what a human can do. Now, I see a big gap. Now, the gap can be because of certain limitations, because yes, the limitations are like we are still yet to understand the human brain. There are research going on. We still don't know fully how the human brain operates. It's infinitely complex, I would say.
Sure.
Now, the second is we don't know what is intelligence.
Hmm.
The third is we don't understand clearly what is consciousness. Like these are some of the things which actually defines a human being.
True.
Now,
True.
to be able to mimic a system as complex as a human being is a system. You can say but I don't see that level of detail going on in making a system like that. Like although that's because we are yet to understand fully what each of these things mean. I mean, how they work, how they operate, where do they come from? I mean, how it gets generated. So all these things. Now, next gap I can see is yes, there are like challenges in computability, hardware resources. Like if we try to even if we try to run a state of the art model, it takes like huge compute power. It
Yeah.
requires a supercomputer. Climate model, you say all these things, intelligent traffic systems, all those, they require huge power. Now this is not something, because our brain operates at amazingly
Yeah.
efficient
Less
level.
than
Like
20 watts. Less than 20
yeah,
watts.
less than 20 watts. See, I mean, it is infinitely complex, but requires less than 20 watts. It's like a bulb, like it consumes. But our systems does not. It takes megawatts.
Yeah.
It's
Yeah.
not
True.
feasible.
True.
So these are some of the gaps which I can see, which is hindering us from going to that level. Although there are research going on, like in the space of neuromorphic AI, memory stars, and all everything, but still there are a long way to go. Yeah, so these are some of the I think that's something which I'm missing, and which is the gap which should be fulfilled at some point.
Yeah, definitely, definitely. There's this idea of like like actual hardware, like the neuromorphic hardware that we can talk about later. And there would be like this idea that would your hardware like actually like mutate at the end of the day? And also like we have talked about inductive bias, we have talked about causation and everything. And yeah, that is a big issue. And like these are some challenges that you have kind of collected. So would you like to explain what are these
Yes,
challenges and what AI would like current day AI will not be able to do?
correct. That's right. No, so these are the few challenges which we have seen, which a AGI system can see. Like if you see this GIF, it is like a baseball batter trying to hit a ball. Now, the question is, what if you remove the bat from the scene? What will happen? Now, if you ask a human being, he very easily will say the ball will hit the batsman, he will get injured. Or if he is careful, if he is vigilant enough, he might move a little and the ball might miss him. So these are some of the
Sure.
outputs, some of the outcomes which a human can tell. Now, if a AI system doesn't know these answers prior, and if it doesn't by understanding the picture, this is what the causality comes into picture. Now if we don't tell the system what to do, and if the system doesn't able to figure it out, the system will not be able to make this kind of predictions, cannot tell something, it will give a gibberish answer. So this is challenge number one. Challenge number two is very simple. Now there's a question. Anna tried to reach her aunt on the phone, but she didn't answer. Now answer the following questions. Who didn't answer the phone? Were Anna and her aunt in the same room?
Yeah.
Now, who didn't answer the phone? Anand didn't answer. Now, where Anna or Anand in the same room? We do not know. The context is not there. But if we tell a AGI system, like there are models like BART, GPT, which actually does this kind of things. Like if you give some question, it will try to generate some answers. Now, those I don't think they are AGI level. That there are chatbots, although there are chatbots which you see that if you ask a question, you will get the answer then and there. But they are not AGI system because those are rule-based systems. Answers are fed prior to that. Now, based on based on your question, it will try to figure out the best answer it can from the database. But those databases have been created by us. It is fed. It is rule-based.
Yeah.
Question one,
Yeah.
answer. Question, answer, like that. Now, this is challenge number 2. Challenge number 3 is very interesting. Now, this kind of pictures we usually see in the competitive exams. We have given a lot to trying to figure out what the next picture going to be. Now, if an AI system does not know what the next picture will be, or if you don't train it, it will not be able to answer. A human being will be able to answer easily because we have seen this kind of thing. Like these are 3 challenges which we there are other challenges, but these are some of the main challenges which we have figured out.
Yeah, I think Tamal, these are like very creative challenges that AGI system would have to be tested upon, and then maybe we can say we have reached to an AGI level. Yeah, definitely, definitely.
That's right.
So yeah, basically based on these discussions, okay, I will discuss the plan, and of course we'll have a free discussion here. And the plan here is to come up with 6-7 videos at the end of the day, discussing various paths that we have to take to reach to AGI. Okay. One of the immediate things that I can see is definitely pattern recognition. One of the widely heralded fields, and like definitely this is on which like whole machine learning is based out of right now. And I would definitely like to see more progress in this field itself. This is something even I know very well. So I think we will be able to have like pretty good discussions, and maybe we can dedicate a couple of videos just based on this itself. And we'd like to look into the existing systems like deep neural networks, reinforcement learning, and we would like to see what is happening, which is going to advance this field. So that is something that I would love to discuss. Then one thing is, again, just I've been pointing it out, we need to talk about knowledge representation, knowledge base, causality, causal learning. Without that, like, it's going to be incredibly hard. Even if you have great pattern recognition system, which we have right now, according to me, it is not going to work very well in the real world. Okay. Then I would like to talk something about neuromorphic. Okay, like what we can learn from brain, what existing models are there, like spiking neural networks are already there. So what we can learn from our brain and what that could aid in understanding or like kind of creating better neural networks, maybe. Okay, third generation neural networks like spiking neural network. And of course, we have different neuromorphic accelerators, hardware, although we would not be the best people to talk about it, but we would try to do our level best to kind of talk about in this general sense what is happening in this field. And then comes the mathematics of it. Like at the end of the day, you have to talk about like, okay, fine, you do everything right, but what is the ultimate model, or like what models are you gonna choose? And recently, Jan LeCun kind of reinvigorated this idea of mathematical model, which is not new. Let me be very, very clear here. And I had read a great kind of the paper by Jürgen's team basically at one point. And I think David was there, Jürgen's a world model. I think it was, I think it came in 2018. And I found that to be a very relevant research in field of AGI. Or like if we want to go to AGI, we have to look into that. Gödel machines were there, right? So these are different ideas that have been there from quite some time, and people are more and more researchers are looking into some grand unified model, world model, which can bring us there. And of course, there are multiple ideas like universal Turing machines, neural Turing machine, echo state networks, liquid state machines, deep residual network, differential neural computers, extreme learning machines. There are like a lot of ideas. Every couple of months, we read some paper where they are discussing some new model. And I would love to kind of contribute in this field. And we would like to collaborate with different people who are interested into this research. And this podcast or this video series is basically kind of step in that direction, that we want to discuss these things, that how we can bring everything together and maybe lead to creation of AGI. So Tamal, like according to you, like which topics you would like to focus on, what major things like we should really be concentrated at, and what you would like to do here?
Yes, so it's a very good question. Now, all the future topics are great. I'm looking forward to the series. There's a lot to contribute, lot to discuss, as you see here. But some of the few important things which I want to highlight here is a causality knowledge representation, because unless we know what causes what, it's very difficult for a system to understand. We humans are good at causality because we understand from the very part that what causes what. So for a system, we have to do that. Next
Right.
is efficiency. It's it is not feasible given our current world conditions that to compute infinite amount of resources. At some point in time in future, few resources will run out. It is clear. Now we need to be able to do some research or come up with systems that are highly efficient in power consumption, compute power and all. So that's why neuromorphic hardware and memory stores are showing promising signs. Now
Sure.
this is the second most important. And the last one, I'll not say last, but at the next or the least we can do is trying to figure out understand the mathematics behind the AGI. Like the mathematical understanding, if we don't have the mathematical understanding of algorithm or how they work or how they produce the outcomes, so it is very difficult to at least design efficient algorithm. So that's where the mathematical parts comes into picture. We need to understand the mathematical part. Yes, there are few state-of-the-art systems networks that are listed at the bottom, like Turing machines, liquid state machines and all. But those are at research level, yes. But if you understand them and how to incorporate them in other algorithms and see how they can increase the efficiency or the power of the algorithm, then it's good. So these are some of the things which I want to focus on. Like I want to see these contribution in these domains. So that's what, yeah. What do you think?
Interesting, very interesting. Yeah, Tamal, I think in this effort, this joint effort will basically lead to something in kind of a form of a serious research in AGI, and hopefully we will be able to meet and discuss these same ideas with different people. Maybe we'll find more collaborators through this effort, and we would like to see some serious progress in the field of AGI. And definitely this was a good conversation, and I would like to thank you for joining us today. And of course, we are going to have more conversations, and thank you all of you for kind of listening to us. And that's all for right now. We'll be coming out with the second video within few weeks. And you can kind of contact us through LinkedIn as well. And we'll be providing you multiple resources and the links of these resources. Okay, so we will see that if we can also provide you the PDF of this PPT. It does has a lot of links in the appendix. Okay, so I think that would really help out people while going forward. So I would really like to do that for everyone, and that can really help out. I think a lot of people who are looking into this AGI research. And we will kind of keep discussing. We'll keep discussing newer ideas. And thank you all. Thanks all of you for attending this kind of and listening to us. And we would love to bring out more content in this field. And we would like your support. Thank you, guys. And you guys have a good day. Take care.
Thank you.
Bye.
Thank
Bye,
you
guys.
all.
Bye.
Bye. Bye.